Hey everybody, today I'll be discussing measures of variation. This is 9.4, and hopefully by the end of today you can say I can find the IQR or the interquartile range. And you can see I've already got a misspelling, I've already flubbed up here. A range of data sets. Okay, so I can find the interquartile range, which um, is a little bit tricky the first time you do it, but it's nothing. It's actually something you've already done before, just finding the median and then finding it a couple more times, and then also finding the range of data sets. So that's the plan for today. For our vocabulary, the section title is measures of variation. So what are measures of variation? A measure of variation is a measure that describes the distribution of a data set. So how our data is distributed. So I'm going to kind of underline that. The distribution, or how it's distributed or spread out. A simple measure of variation is the range. So one measure of variation is the range. The range is the difference between, so difference, remember, means subtract, between the greatest value and the least value. All right, so that won't be too hard. We just subtract our biggest number and our smallest number. The table shows the lengths of several Burmese pythons captured for a study. I would not want to run into one of those guys. Find and interpret the range of their lengths. All right, so you can see here we've got the different lengths of these pythons that were captured. Sometimes they'll tell you order the data from least to greatest. I'm just going to look at my data here. I see I've got my smallest number, the smallest Burmese python that was captured, which, if you don't know, it's a snake, is 5 feet. And the greatest, or the largest, looks like 18.5 is my biggest number. Okay, 18 and a half feet. So to find the range of this, that means I'd have to take 18.5 and subtract 5. All right, bring my decimal straight down, and 18 minus 5 would be 13. So my range would be 13.5, 13 and a half. And what does that mean? This means that the lengths vary no more than 13 and a half. So our smallest one is 5 and our greatest is 18 and a half. Your range won't get any bigger than that. All right, go ahead and try that on your own. It says the ages of people in line for a roller coaster are as follows. Okay, these are their ages. Find and interpret the range of their ages. Okay, so what is my biggest and what's my smallest number? Looks like 52 is my oldest age. Minus my youngest, I've got a 15. Looks like 15. So 52 minus 15. I borrow. 12 minus 5 is 7. 4 minus 1 is 3. Is that right? Oops, it's not right. And maybe you saw it before I did. My smallest number looks like it should be 11. Okay, let me try this again. 52 minus 11. 1, 4. Okay, sorry, I flubbed up there. And that's actually something that can happen if you don't order your numbers least to greatest, like I didn't there, and I was just kind of skipping ahead. Be careful that you just don't misread your numbers. So 52 minus 11, I get 41 for my range. So that means the ages of people in line vary no more than 41 years. All right, let's take a look at our key idea for today. And here is where we're going to talk about what I introduced in the beginning, the interquartile range, or the IQR. So first off, quartiles. What are quartiles? The quartiles of a data set divide the data into 4 equal parts. That makes sense because quartiles, the root word there is quarter, and there are 4 quarters in a dollar. Okay, it divides the data set into 4 equal parts. Recall that the median, which is technically the second quartile, divides the data set into halves. It gives us the first half and the second half, right? And the lower half, so here's my median. The lower half is called the first quartile, and the upper half is called the third quartile, right? I usually refer to it as the upper quartile and lower quartile, like it says over here, but you will hear both. All right, so you got to know first is the lower and third is the upper. To find the interquartile range, you take the difference between the third quartile and the first quartile, so you subtract these two. The IQR represents the range of the middle half of the data and is another measure of variation. Just like we did range first today, now we'll do interquartile range. It's another measure of variation, of how much your data can vary or change, right? IQR represents the range of the middle half of the data, right? Once we, when we're talking about box and whisker plots, remember that this middle line in your box and whisker plot is your median. This is your lower half, and this is your upper half. And that represents half of the data, 50% of the data. And the interquartile range is a good measure of that. So let's see a problem where we have to find the interquartile range. See if we can figure that out. The dot plot shows the top speeds of 12 sports cars. Find and interpret the interquartile range of the data. So the IQR. First, what I like to do is I like to list my numbers from least to greatest from this dot plot. So I have 220. I have 2 230s, 2 240s, 245, 3 250s, 260 I have twice, and 270 is the top speed of one sports car. That's flying. I can't imagine that. First step, what we need to do. So first we need to find the median, right? So sometimes I underline, work my way towards the middle. One small, one big, one small, one big. Again, I'm just working to find my middle number. Okay, I have 2 middle numbers now. So remember, when I have 2 middle numbers, I need to find the average of them. So 245 plus 250 divided by 2. Okay. Or you can kind of think to yourself, if I went 2 up, I'd be at 247. If I went 2 down, I'd be at 248. What's between 247 and 248? Well, that would be 247 and a half would be our median. So that's going to split our data in half. We'll have 1, 2, 3, 4, 5, 6 numbers on the left side and 1, 2, 3, 4, 5, 6 numbers on the right-hand side. Then I need to find what's the median of my lower half. So cancel there, cancel there. And then what's in the middle of 230 and 240? That would be 235. Cancel, 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 cancel. What's between 250 and 260? That would be 255. Okay, so now when I'm finding my interquartile range, I take my third or my upper quartile and I subtract that from my first or lower quartile. So I will take 255 minus 235, my third minus my first, or my upper versus my lower, and that gives me a total 255 minus 235 of 20. So, oops, my zero disappeared. So what does that mean? This means that the middle half of the speeds vary no more than 20 miles per hour. I'll say that again. The middle half of the speeds, let's write that down. The middle half of the speeds vary no more than this 20 miles per hour. Okay. So essentially, we're finding the median 3 times. It's kind of how interquartile range works. All right. The last example deals with checking for outliers based on our interquartile range. You can use the quartiles and the IQR to check for outliers. Any value less than, excuse me, I had to sneeze here. Any value less than the quartile 1 minus 1.5 times your interquartile range is an outlier. And any value greater than what we found for our third quartile plus 1.5 times the IQR is an outlier. Okay, so anything way too high or anything way too low. And we have this formula to use. So I would kind of star this and remember formula to check for outliers. All right, so you can come back to that and double check that. I'm just going to highlight that here quick. All right, so in this last example, that's what we're going to do. Check for outliers. Check for outliers in the data set in example 2. All right, so let's use these formulas that we were just given. Q1 minus 1.5 times the interquartile range. All right, what was our first quartile? Scroll back up here. First quartile we found was 235. So 235 minus, okay, first we need to multiply here. 1.5 times our interquartile range. Remember, what we found for our interquartile range was 20. So 1.5 times 20 will give you what? Well, 1.5 or 1 times 20 is 20. 2 times 20 is 40. So what's between 20 and 40? That'd be 30. So 235 minus 30 would give us 205. Now we need to look and see, are there any values less than 205? Scroll back up to our data. Are there any values less than 205? No, there were not. Okay, so I'll put no values less than 205. So we don't have any small outliers. Now let's check for if we have any outliers that are bigger. So now we're going to take the third quartile and we're going to add 1.5 times our IQR. Our third quartile we found was 255. 255 plus, okay, remember our interquartile range was 20. So 20 times 1.5 again is 30. So 255 plus 30 gives us 285. So we're checking to see now, are there any values greater than 285? Let's check it out. Nope, our greatest was 270. So there are, get back to my pen here, no values greater than 285. So what we can say, so there are no outliers. All right. So again, using this formula will really help you check and see if there are any outliers. Go ahead and pause the video now. Try the last on your own and see what you come up with. Right. For your interquartile range, you should have come up with 38. And then, does the data contain any outliers? And then this one, yes, the data does contain outliers. The boundaries for outliers, you should come up with 303 and 455. Kind of like our boundaries here, we had 205 and 285. The boundaries here were 303 and 455. None of the numbers are less than 303, but one value, 468, is greater than 455. So our outlier, so 468 is our outlier. Okay. If you didn't get that or you have questions on that problem, let me know and I can help. That does it for the fourth lesson on measures of variation with range and interquartile range. Good luck on the homework. Let me know if I can be of more assistance, and I will see you next time.